Hi, welcome to my channel, JaberTime, where I do math videos simplified with examples from algebra to calculus and differential equations. Recently, I just finished the Calculus 1 videos, and now I'm starting both Calculus 3 and College Algebra. If you're new here and you like this video, hit the like button, subscribe, and leave me any comment below if you have any concerns or any comments. Hopefully, I will see you again and again. Thank you for watching, and let's get into it. The first video for Calculus 3 that I have for you here is three-dimensional coordinate systems. And I have a graph for you right here that shows pretty much everything. We are on the first part. They don't call it part. They call it octant. In two-dimensional, we call them quadrants. So let's move on. This right here is the X and Y and Z. To stay focused, I have notes. I don't want to go off the notes, and I rewrite notes ahead of time to save you the time through the video, and also to stay organized and cover more. Because if I write or graph these ones while I'm recording, that's going to take a lot of time. So I preferred to write my notes, go over it, make sure that to the best that I can, there is no mistakes, and I will start recording. So this right here is the positive x-axis, the positive y-axis, and the positive z-axis. Of course, they extend to the back, but I just want to stay focused with you here. This point right here, a point P, is ABC. A for x, B for y, and C for z. If you drop this down to the xy plane, that means the z coordinate has to be 0, as you could see right there. So any point right here aligned with this point as a drop down with 90-degree angle, that will give you A, comma B, comma 0. If you want to drop it on the y-axis, you are actually eliminating the x. There is no x anymore. You're not sticking out or going out in the x direction. So x will be 0 and z will be 0 because you're down. Let's call it the floor. And only b is staying with you for the y. So those are called the z-intercept, the x-intercept, and the y-intercept. Let's move on. Now, right here, the x, y, z, you want to make sure that you do it this way. You can't write x here and y here and z here. So x and y cannot be switched, just like to give you a comment. The coordinate axis, it's called, or to refer to help you understand it, it's called the right-hand rule. So if you use your hand and you go right from x towards the positive y, as you could see, you are pointing up to the z-axis. It has to be this way. It's a rule. I mean, we have rules in math that we can't just like have some people in different places do it their way and we do it our way and so on. It doesn't work this way in math. So if we, for like order of operations, if we agree that we want multiply to come before addition, and some places in the world they go like, no, we like to add first before we multiply, that's not gonna work. So let's move on. In the xy coordinate system, as simple as that, x and y, we call this one quadrant 1, quadrant 2, 3, and 4, counterclockwise. Of course, there's more detail into it. I'm not reading it. It's just like introduction to Calculus 3. This is an interesting class, by the way, just to let you know. It's all about three-dimension. Calculus 1 was just like plane on the whiteboard, x and y axis, and integration with Riemann sum, just flat on the whiteboard. So two-dimensional. In this videos for Calculus 3, we're gonna focus more on three-dimension. Imagine Riemann sum in three-dimension, and there is more into it. So the xy coordinate planes, these three coordinate planes, the xy plane, the xz plane, and the yz plane, divide the space into 8 parts called octants. The first octant in the foreground is determined by the positive x and y and z axis. So that's called the first octant. You could call it room. It's almost like you have walls between rooms. And this right here, the z axis, is kind of like a center that these 4 rooms on top, they share this corner of the rooms. Underneath it, let's say this is level 2, this is level 1 down here, I still have another 4 rooms. So we do end up with 8 octants. Back to this. As you remember, this is what we have, the 3-dimension graph by hand. I like to graph by hand to the best that I can. To reach to point P, which is ABC, you could start with A, then go B, then go C. That's just like when we do like in the X and Y axis. So you reach out A amount on the X direction, B amount on the positive Y direction, Z amount, or C amount, sorry, in the positive Z direction. What do I mean by this? This is what I mean. Okay, so you go A, B, and C to reach out to the point A, B, C. The point A, B, C determined a rectangular box. If you drop a perpendicular from point P to the XY plane from this point down here, we get a point Q with the coordinates A, B, and 0. Notice that 0 for the Z value because we're not up there, we're just down on the XY plane. Called the projection of point P on the XY plane. Alright, let's show you more. The point R, which is on the YZ plane, as you can see back there, has no X value in it, which is X equals 0. And this point here is actually the projection of this point ABC on the XZ plane. That means Y value is 0. So those are interesting points for coming graphs. You need to know how to find the x-intercept, the y-intercept, and the z-intercept. So the Cartesian product describing this right here is r times r times r, which is x, y, z, as x and y and z belongs to the real number system. That's a 3-dimension Cartesian product. Is a set of all ordered triples of real numbers and is denoted by r to the third. Of course, we write it this way to distinguish between the regular r and the real numbers system. Here's an example. What surfaces in r to the third are represented by the following: z equals 3 and y equals 5. Of course, we are in 3-dimension, so it's kind of simple. So if you feel like I'm going too fast, I believe you could follow me, and it's not really complicated, but it's good to see them as introduction for the coming videos too, because we're going to be graphing 3-dimension. Z equals 0, that means you go up 3 units in 3-dimension, of course, and stay up there. So it's not going to be a horizontal line like back in the XY plane. We describe it by the XYZ sets such that, that's how we read this, z equals 3. The set of all points in r to the third whose z coordinate is fixed to be 3. This is the horizontal plane that is parallel to the XY plane, which I keep calling it floor because whenever I teach in my classroom, I kind of like walk around and call the XY plane as a floor, and I look at the right wall, left wall, standing in the corner telling the students what's the XY plane and the YZ plane. Alright, and is 3 units above it, above the XY plane. This is how it looks like. Hopefully that graph is clear. You go up 3 units with the z positive direction, and you keep it this way, so all the points that belongs to this horizontal line that is parallel to the XY plane. Let's look at y equals 5. So we're going to go right because my y is to the right, not like the two-dimensional plane, and you keep it as y equals 5. You stay right there. This is the vertical plane that is parallel to the XZ plane, and 5 units to the right of it. This is the XZ plane, and we move to the right 5 units, and we keep it right there. Describe and sketch the surface in r to the third represented by the equation y equals x. That's more interesting than the first ones. So the equation represents the set of all points in r to the third with this condition given to you. Y and x coordinates are exactly the same. You could call them x and x, you could call them y and y, doesn't matter, but as long as you keep that in mind, 5, 5, 1, 5, 5, 5, 3, 5, 5, 7, and so on. So these has to be equal, where x belongs to the set of real numbers and z belongs to the set of real numbers. This is a vertical plane that intersects the xy plane with y equals x. That's my condition. And if you want to intersect the xy plane, you are saying I'm not moving up, I'm not moving down, so z equals 0. The portion of this plane that lies in the octant is sketched below. Here we go. So when you are looking at the plane x and y, and you're saying y equals x, that's this line. It's a 45-degree from the positive x-axis. But since we are in 3 dimension and z is loose, has no restrictions, I'm gonna go up and I'm gonna go down, always left and right, of course. So it's a vertical plane. The projection or the intersection with the xy plane is just the line y equals x. Let's look at the distance formula in 3 dimension. So the distance formula in 3 dimension is similar to the distance formula in 2 dimension, except it has another z part into it. And what's interesting about the distance formula, it's like finding the hypotenuse in Pythagoras theorem, because that is actually a square root of a squared plus b squared, which is a distance formula. In 3 dimension, it's a Pythagoras theorem in 3 dimension. So we're going from point 1 to point 2 as stated. Distance, we kind of refer to it as absolute value, will be the square root of a squared plus b squared plus c squared. It's a 3 dimension. So if you want to go from this point all the way to this point, that's kind of like a main diagonal to this box in 3 dimension. You're gonna go x difference, y difference, and z difference. x2 minus x1, y2 minus y1, and z2 minus z1. Kind of like in hypotenuse, we call them the legs. A and B, A refers to x2 minus x1, and so on. Pretty much the same concept. So that's my difference in x, and that's my difference in y, AB, and that's my difference in z. Hopefully that's clear. As you can see, I'm going a little bit fast, but I think you could follow me. And to save you more, as you could see, and cover more, save you time and cover more, I take the time to write and graph these notes for you guys. And let's just move on. The distance from the point 2, -1,7 and the point 1, -3,5 is, just apply the formula, there is nothing much in it. Since this is my endpoint, doesn't make any difference. 1 minus 2 will go here, square it. -3 minus -1 becomes plus, square it. 5 minus 7 and square it. Take the square root, and that's going to be square root of 9, which is 3, and that should do it. Now let's look at the equation of a sphere in 3 dimension. For a sphere in 2 dimension, it's like a circle. In a sphere, it has like a, imagine a circle that has 3 dimension, so it's gonna look like a sphere. An equation of a sphere with center HKL and radius R is, looks almost the same like a circle, if you notice, right? It's just like another part to make it 3 dimension. In particular, if the center is the origin, then the equation of the sphere is x squared plus y squared plus z squared equals r squared. Here's an example. Show that this right here, the whole package, is an equation of a sphere, and find its center and radius. Notice that I'm not reading it because I want to save some time, and I do have it coming right here in a larger font. That's the same thing, all right? So it's x squared plus y squared plus z squared plus 4x minus 6y plus 2z plus 6 equals 0. The way I write my notes, the way I explain, and it's kind of like, I think it's an easy way to go back to it. So if you watch the videos and you want to go back to the videos, you could see it quickly. What do I mean and represent? I use different colors. I kind of underline things, highlight things, my style. Going back to it will be so easy to understand compared to textbooks. All right, so here we go. So I'm rewriting the whole thing, but look what I did. I wrote this x's in black, y's in green, and z's in blue, and I moved the 6 from the left side to the right side, away from them. What do you think is going on? Notice also, I'll give you a hint, I left some space here, and I left some space here, and I left some space here. I think you guessed it. We're gonna complete the square, and I believe you know how to complete the square. It's kind of hard to go in detail in calculus 3 with all the algebra ideas. I call them skills, but let's just take one quick. I'll take the middle one. We look at the coefficient of y, which is minus 6 divided by 2, that's negative 3, square it, that's 9. So you add 9 to both sides to keep it balanced and keep the equal sign valid. Now this becomes a complete square, and that's factoring skills. That is x plus 2 to the second, and it's a square. X plus 2 times x plus 2. That's why we call it complete the square, not a rectangle. It's a square, 100% a square. Same thing here, same thing here. And if you compare this to the formula that we have, that is actually an equation of a sphere with the center x minus minus 2. If you remember, it was saying minus, so you have to be careful with the negative signs. This is already written minus, so that's a 3. That has to be a minus. Z minus negative 1 was simplified to plus 1, so you have to be careful. And 8 is square root or cubic root. Square root. I get this question once in a while from students. They say, do you have to simplify this? I go like, you know what? The problem doesn't say that, and we are in calculus 3. If you could simplify and show clear understanding of the whole concept, we're not too worried about simplifying this. And we're not saying round your answer to 2 places, 1 place, to the hundreds. We're not saying anything. As long as you're doing it right and you know what you're doing and you show understanding, you are totally fine. All right? Now, what region in R to the third is represented by the following inequalities? This is an interesting graph. This is clear. We know how to see it, but with inequalities, 2 inequalities, that's maybe a little bit harder, but we'll do it with the condition z less than or equal to 0. So remember when I keep saying floor in a classroom? That's the XY plane. You are standing on the XY plane, and underneath it belongs to you. All right? That's what this means. To stay focused, I have the notes. As you could see, I don't want to go off a lot. This is the same. Rewritten again. Take the square root of all 3 sides. So they represent the points XYZ, whose distance from the origin is at least 1. At least 1 means greater than or equal to 1. And at most 2. That means less than or equal to 2. But we are also given that z is less than or equal to 0. So the points lie on or below the XY plane. Now, the given inequalities represent the region that lies between or on, because I do have the equal sign. If it doesn't say equal here, just less than, and here it says just, of course reading it from this side, greater than, without equal sign, that means we have regions of spheres but without the surface. Okay, but here we are including the surface. Imagine if you could read these two inequalities as separate two inequalities. This is a compound inequality. If you read this by itself, that's 1, and if you read this by itself, that's 1. If you set the equal sign, you're looking at a sphere. With the inequality, you're looking at the sphere and what's inside it. That's what we have. So this is a sphere centered at the origin with radius 1. This is a sphere centered at the origin with radius 2, because that's r squared. And you are between this sphere and between this sphere, you are between both. You're less than or equal to a radius of 4 sphere, but also greater than or equal to the inner sphere, and beneath or on the XY plane. Because of this condition, I don't want to keep repeating myself. I would prefer to show you the graph so you could see it. If you continue this all the way up, that's a sphere of radius 1 centered at the origin. If you continue this all the way up and complete it as a sphere, that's another sphere centered at the origin with radius of 2. But what is happening right here, you cannot be above the XY plane, so it's cut with a sharp knife, as you could see, and you are less than or equal to, belongs to a sphere with radius of 2 and the inside part of it. So you are inside the outer sphere, outside greater than or equal the inner sphere, and not above the XY plane. So it's almost like I'm saying to you, this is empty, and kind of like a seed, and this whole thing is yours. Hopefully that was clear. There is more coming, and this is just an introduction. If this is your first time here, just want to let you know there is more and more coming. I cannot be committed to 1 or 2 videos a week, or Tuesdays or Thursdays as others. I have a lot of classes that I'm teaching, but I am so committed to those videos, and they're gonna be up. So if you like this video, hit the like button, subscribe if you have not yet, and I'll see you in the next video, which is gonna be right after this. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.